Okay, problem number 1. Who can tell me if that's an input or output by raising your hand? Lily?
Input.
Input. So 0 comes in. What needs to come out?
Output.
And what number is that in this case, Lily?
2.25.
I got about 2.25. 0 goes in. 2.25 comes out.
It's not even funny anymore.
So, on problem number 2. Ella, is that 12 an input or output? So 12 goes in, what comes out? Yeah, something about 0.9-ish, right? There it is. I put a dot there even. All right. Problem number 3. Grant, is 1 going to be going in or coming out? Output of 1. So what input do I need to get an output of 1?
11.
About 11, yeah, right there. 11-ish. So one way you can write that is like this. You could write m equals 11, or you could write it as the function of 11 equals 1. Both of those would say the same thing. X is 11 either way, or m is 11 either way. And number 4, is 0 an input or output, Sanaya? Input. Okay, so I'm going to point to right here. The x value is going to be our input. So our input is unknown. So what does this need to be, Sanaya? Thank you. So output of 0, what do I need to put in to get 0 out? Who's got an answer for me raising their hand? John.
19.
And I said 20. I said 20. But you don't think it's quite through it?
I think it's just before.
Either one of those answers says the same thing. I got 20, but if you had 19 but had the right idea where we were, you're all set. All right, so everybody seeing this? We got ins or outs? Okay, this is from yesterday's section checkpoint.
Gosh.
Yeah, okay, minute 50. Okay. So, just keep in mind big ideas as you do all these things, because then it's not such a monumental task if it's like, oh, I didn't see one that looked exactly like this before. All right. Okay, here's what you're going to do. This is where we're going to get the shot at the hoop today. There is a toy rocket and a drone, and they're both getting let go or shot at the same time. Don't shoot drones. Taken off or shot up, whatever. They're taking off at the same time. Here, the rocket is function R. The drone is function D. I'm looking for the most detailed description of the functions using words and numerical values. Where someone does not see this could make it by what you write down. The most detailed individual will get a prize out of the prize bin. You don't even have to make a shot at the hoop.
Let's make it.
Then I'm going to try to pick 3 other individuals with a lot of detail to shoot shots for a prize. Everybody individual, even if you're out of group. Let's go. All right, Dave, I'm going to come back to you because I'm going to catch this on this video. Rocket description. It's just your voice, not your face, okay? Okay.
So I start now.
Yeah, get started.
Okay. The rocket took off approximately at 20 meters. Then the rocket exited its parachute from its storage compartment and began the descent, 45 meters for approximately 2.5 seconds.
Okay, I can see that.
That is all.
I think I had 25 meters, but you said approximately, so 20 and 25.
That's
okay.
what I meant.
And then you said something 45 meters at the peak. I used the word maximum when I did it, but same idea, I could follow. And then 2.5 seconds to get to the ground, so it must have reached its peak at 2.5 seconds.
I
what
would
you're
say
saying.
that's pretty detailed.
Okay, who's got a drone? Who's got a drone for us? All right, Claire. Everybody's supposed to have both. But. Okay, Claire.
The drone starts at 0 meters, increasing by 20 meters by 2 seconds, staying at the height of 20 meters for 3.5 seconds till decreasing back to 0 meters by 7 seconds.
Okay, I like the use of the word rate. 20 meters over 2 seconds. Did anybody go 10 meters per second on that to get a unit rate or a slope? Okay, that's cool. So yeah, we have some good descriptions. As I walk around, you guys make it hard, so I won't put it in the video, but let's select our winners of the most detailed descriptions. Now we're going to move on to a Desmos activity. You're going to need your device. I assigned it to you on Desmos. So everybody needs to get on Desmos. So here's what you're going to do on this slide. What you're going to do on this slide is, when you click the meaning, it highlights the portion of the graph it is talking about. So you and your partner are going to click through the terminology, and you're going to come up with a definition for that term based on what you see in the graph. I think this should only take 2 or 3 minutes. Okay, so let's talk about positive aspects. I'm going to highlight it there. Who can tell me what they notice about all the positive values? Alex?
All
points of the lines, like they're above the x-axis?
It's above the x-axis, which means all the positives are positive outputs, y value. It's where all the y's are positive. What do you think positive gets mixed up with the most in this terminology? Who can raise their hand and tell me which one? Nico, which one do you think? Slope. So slope can be positive, but does slope have to be, something with a positive slope, does it have to be above the x-axis? No, so it's not positive slope. Positive in terms of a function is above the x-axis. So since we did positive, let's talk about negative. Who could say what negative means in this context? Alice?
The lowest point in value, so it's like, well, kind of, sorry, there was a
No, we did positive, now we're at negative.
Okay, so negative is like when it's below 1.
Below the x-axis, all the outputs are less than 0, which means they are negative. Let's talk about the maximum next. Victor, what do you notice about the maximum on all of them?
It's the highest point.
The highest point. Why do you think there's not one on the top right? That graph must do what?
It must not have
It must keep going, right? So there is no maximum. Speaking of maximum, Audrina, what about the minimum? The lowest point. Who can tell me what's true about all these graphs where it's increasing? Aoife.
They're going up.
Kind of. You got to be careful.
From the...
From left to right, they're going up. Kind of, but they're kind of curvy, so it's not necessarily slope, right? So increasing is up, left to right. We have to say left to right because otherwise you could go up, right to left, and then it's not increasing, right? So left to right, which means decreasing must be going down. Yelling timber, left to right. Not necessarily slope, they're curvy. Slope only applies to lines, straight lines, okay? All right, next up for your Desmos. You are going to build a function and then use some of that terminology to explain. Some things I'm noticing about Lily's. It looks like it has a minimum of something like close to -3 or a little more negative than -3. It has a maximum just over 5. I have increases on the left side and on the right side. I notice that I am positive for part of it and negative for part of it. And I could reference those with intervals. Let me see here. So let me highlight. Increase here, decrease here. That's the only decrease, actually. I already referenced the maximum and the minimum. Okay. And all this up here is positive. All this down here is negative. So you could use like specific intervals. I'm just trying to half speed run that so we could look at another example as well. Okay. Let's look at one. Okay, Deus, this one looks interesting. Okay. So, some things I'm going to point out. I got 3 different of the same maximums. This is a minimum right here. These values up here are positive. These values down here are negative. Here are my decrease areas. Oops. Decrease, 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 decrease. And here's my increase areas. Increase, increase, increase. And if you ever want, so that's cool. We can use all this terminology to describe functions. What you're going to do now is try to match a function with some descriptors. So, this one needs to always be positive and have a maximum of 2, 4. It can be more than one of these, so let's see what you choose. So, always positive excludes this one. Are you guys seeing that? Because that chunk. Okay, next. Maximum of 2, 4. I've got it right there. Don't have it there. Have it right there. There we go. 2 answers. There we go, Latifah. Makes me think of this. Do kids know who Queen Latifah is? She was a popular rapper, comedian, actress when I was a kid. Queen Latifah. She's still around?
Oh, I know.
Okay. All right, next up. You are going to draw one that has a function that is increasing when x is greater than 0. So your function needs to increase when x is greater than 0 and have a minimum of -3, -4. So taking a look, it could be a lot of different functions, but here's how I'm going to go through this. I know it's got to go through this point. That has to be my minimum. And I know when I'm right of 0, it needs to be going up. So like this, none of this kind of matters. I can go like wherever here. Let's say I go right here, but then from here on, it needs to be increasing. And then over here, it kind of doesn't matter what it's doing. I just need to go through this point, and from this line to the right, it needs to be going up. All right? Lots of different functions will work for that one. Next up, Andrea. Positive when it's greater than -2, but decreasing when it's greater than 1. Do it and check it. You got 2 minutes. So check it out. Positive when greater than -2. So it doesn't matter what happens over here. But when I get right of -2, I've got to be above. Okay? So I actually going to go up pretty quick here. When I'm above 1, it needs to be decreasing. That works. So when I'm right of 1, it's going down. So when I'm right of this line, it's going down. And it needs to be above the x after 1. So after x being or greater than -2, so right there, it has to be above there. It satisfies both. Okay, we're going to next run over to the lesson summary in your lesson summary notes. Let's see, it's right here. When your lesson summary is done, homework's in the top basket. Let's go.